Welcome. So we're going for the second part of the rules of differentiation for trigonometric functions. So we'll see the cot, the sec, and the cosec functions. So the first one, the cot. So it says that if you have cot of u, cotangent of u, and u is a function of x, what we basically do to find its derivative is we differentiate again the argument, which in this case is u, and then multiply by cosec square of u, the argument without any touch. Look at this function. Y is equal to cot 3x squared plus 5. This is the argument. So what we do in this case is we have to, there's a minus here, always pay attention. So this is the argument, and then what we do now is to differentiate the argument and then multiply it by cosec square of that argument, and all this should be negative. So let us see how we do it. So y dash is equal to, again this is the power rule, power of x. So what we do now to differentiate this, we can do it in the other side. This is 3x squared plus 5. So what we have now is 6x plus 0. This we can call as g of x, g dash of x. So this is the derivative of the argument. So we make minus derivative of the argument 6x multiplied by cosec square of the original argument 3x squared plus 5. Easy. The next is derivative of a sec. Again we have the argument, but now what we do is we differentiate the argument, we multiply by the secant of that argument and multiply again by the tangent of that argument. Look at this example. We have to find y, that's what we do. I hope you still remember that this was one of the cases we've seen about exponential functions. So what we do in such case when we have e raised to say something u, what we do to find the derivative of this function is u dash multiplied by e, again the same power. So that's what we will do over here. Y dash is equal to derivative of this argument 6x, derivative of 6x will come down as here, so it becomes 6 multiplied by e into 6x. This is the derivative of the argument. Now it's multiplied, all this is multiplied by the secant of that argument and also by the tangent of that argument, and it's done. Derivative of a cosec, which is the last point for trigonometric functions. What we do basically, negative sign, derivative of the argument of that cosec function, then multiplied by the cosec of that same argument, multiplied by the cotangent of that same argument without an alteration for those two. We see here, for example, this is the case of power of x that we've been solving. So what we do now is the derivative of this is, the function is 6x squared. Derivative of this will come down and then we reduce the power by 1. So 12, which is 2 by 6, 12x raised to 1, but we don't need to write it. So in this case what we'll have is y is equal to derivative of this, we have found now 12x multiplied by the cos of cosec of that same 6x squared and multiply by the cotangent of that 6x squared. All this is multiplied by minus 1. So our y dash is equal to minus 12x cosec 6x squared cotangent 6x squared, and it's done.